Hello friends. The lift is a type of vertical transport equipment that moves people or goods between floors of a building. Generally, lift is powered by electric motors that either drive cables, hoist, or pump hydraulic fluid to raise a cylindrical piston like a jack. Elevators are of two types. 1. Hydraulic elevator. 2. Traction elevator. Hydraulic lifts are powered by electronic pumps which transmit the hydraulic fluid to the jack. The lift has a piston at its base which will push it up. On the other hand, traction lifts use ropes, sheaves, and counterweight for moving up and down. Both systems have their own set of pros and cons. Traction elevators are the most widely used elevators all over the world. Shaft. It is also known as hoistway. It is the space in which one or more elevator car moves. This space is enclosed by fireproof walls, pit, and ceiling for the travel of one or more elevators. Headroom. It is also known as overhead. It is a part of shaft between the level of the highest stop and the shaft's ceiling. Travel height. It is the length of cabin's travel between level of the lowest and the highest stop. Pit. It is a part of shaft below level of the lowest top. So if we want to calculate shaft height, it is equal to pit plus travel plus overhead. Machine room. It is a special room accessible only for the authorized persons which contains the lift drive unit, control panel and motor. It is often placed above the shaft on the very top floor. The machine room is an integral part of the elevator. With advancements in technology, the machine room is getting smaller and smaller every year, and some systems even have them installed inside the shaft. They are also known as machine roomless elevators or MRL elevators. Guide rails. They are generally made of steel and their shape is like an English letter T. They are installed vertically in a shaft to guide and direct the course of travel of an elevator car and elevator counterweights. Drive unit. Drive unit is generally placed in machine room and it is used to operate the movements, speed and torque of an elevator. If your elevator often suffers from slow starts and stops or seems to make sharp, sudden movements, the drive could be to blame. Control unit. It is also known as controller or control panel. It is placed in machine room which is generally at the top of the elevator shaft. When we press any button in a lift, the signal goes to the control unit and then it is translated through the system to tell the motor whether to move up or down. Once the elevator has reached its destination, there is a signal sent to the control room for it to either stop and let passengers board or exit it. Counterweight. It is a unit consisting of steel weights which counterbalance the weight of the car and to which the suspension ropes are attached. The weight of counterweight is equal to weight of car itself plus 40 to 50% of total weight it can carry. You can see in this picture, the car is located here. When the elevator car goes up, the counterweight goes down, and vice versa, which helps in three ways. The counterweight makes it easier for the motor to raise and lower the car. Just as sitting on a seesaw, assuming the seesaw is properly balanced, you can bob up and down any number of times without ever really getting tired. Quite different from lifting someone in your arms, which tires you very quickly. Hence the motor needs to use much less force to move the car either up or down. Suppose the lift is loaded at its full capacity, which means it weighs more than the counterweight. But in this case, the motor has to lift the difference in weight between the two and supply a bit of extra force to overcome friction in the pulleys and so on. Since less force is involved, there is less strain on the cables, which makes the elevator a little bit safer. The counterweight reduces the amount of braking the elevator needs to use. Imagine if there were no counterweight. A heavily loaded elevator car would be really hard to pull upwards, but on the return journey, it would tend to race to the ground all by itself if there were not some sort of sturdy brake to stop it. The counterweight makes it much easier to control the elevator car. Guide shoes. Guide shoes are the devices which are used to guide the car and counterweight along the path of the guide rails. There are two types of guide shoes. One, roller guide shoes, roller guides, and two, sliding guides. Roller guides use rollers that rotate on guide rails. It has a set of 3 wheels that roll against the guide rails. You can see roller guide shoes on rails in this picture. Sliding guides. Guide shoes which simply slide along the faces of the rails. The sliding insert or jib may be metal, requiring guide rails to be lubricated, or may be plastic material which is self-lubricating. Guide shoes shall be made of cast iron, brass, or synthetic materials such as nylon, fiber-based hilum, etc. Sheave and motor. Sheave, also known as pulley. It has grooves in it and lets the rope be lifted, raised and lowered. It is the motor that keeps the sheave moving in the correct direction, taking people where they need to go. Speed governors. Most elevators have an entirely separate speed regulating system called a governor, which is a flywheel with mechanical arms built inside it. Normally the arms are held inside the flywheel by springs, but if the lift moves too fast, they fly outward, pushing a lever mechanism that trips one or more braking systems. First, they might cut power to the lift motor. If that fails and the lift continues to accelerate, the arms will fly out even further and trip a second mechanism applying the brakes. Some governors are entirely mechanical, others are electromagnetic, still others use a mixture of mechanical and electronic components. It is usually attached to the bottom of the car and it is also known as governor rope. Cable or rope. Elevator ropes are highly engineered and made of steel with other composites. Also, they are not single wires but several strands of various sizes wrapped together. A typical cable or rope can have over 150 strands of wire precisely designed to be strong, flexible, and give long life. The buffer is an apparatus located at the bottom of elevator which is designed to protect people and malfunction of an elevator control system. Buffers can stop a descending car by accumulating or dissipating the kinetic energy of the car. You can see in this picture, buffers may also be fitted under the lift car or counterweight. Buffers can be of two types: energy accumulation type buffer and energy dissipation type buffer. Energy accumulation type buffers may be used only with lifts having a rated speed up to and including 1.5 meter per second. For example, spring buffer. Energy dissipation type buffers may be used whatever may be the rated speed of the lift. For example, oil buffer. Lift safety gears or brakes. Everyone who has ever traveled in an elevator has had the same thought. What if the cable holding this thing suddenly snaps? Rest assured, there is nothing to worry about. If a cable snaps, a variety of safety systems prevent an elevator car from crashing to the floor. Each car ran between two vertical guide rails with sturdy metal teeth embedded all the way up them. If the running speed of elevator car exceeds the set speed by elevator, or if the elevator suspension rope breaks down, elevator safety gear stops the elevator car and holds the elevator car at the elevator guide rail. Usually these brakes are installed on the elevator car or counterweight frame. Lift safety gears are of two types: instantaneous and progressive. If the car speed is less than 1 meter per second, then instantaneous type of safety gears are used. And if the car speed is above 1 meter per second, then these type of progressive safety gears are used. Capacity. To prevent overloading of the car by persons, The available area of the car shall be limited and related to the nominal or rated load of the elevator. For calculation of number of passengers, as per Indian standard, number of passengers is equal to rated load divided by 68. Here 68 is the weight of one passenger in kilogram. Whereas as per European standard, the average weight of passenger considered is 75 kg. Speed. What is the suitable speed of elevator? If it is too fast, then it will result in nervous breakdown to the user. And if it is too slow, then it will cause lack of function of electrical panels and power outlets. Cabin. It is also known as car. You can see in this picture, this is the main part of elevator which is designed for enclosed transport of passengers and goods. It is usually a heavy steel frame surrounding a cage of metal and wooden panels. Cabin is the place where the passenger truly experiences the elevator. Cabin can be of one opening, two opening, angle opening, and three entrance cabin. One opening cabin has a single entrance. Two opening cabin has two opposite entrances. Angle cabin has two entrances situated at an angle of 90 degree. And three entrance cabin has three entrances. Elevator cabinets shall be completely enclosed by walls, floors, and ceiling. The only permissible opening being are the car door, emergency trapdoor, and ventilation apertures. You can see in this picture, emergency trapdoor is placed on top of the elevator car. Car floor. Car floor shall have sufficient mechanical strength to sustain forces which will be applied during normal operation, safety gear operation, and impact of the car to its buffers. Floor will be recessed and covered by PVC covering or marble stone or granite, and it can be also customized according to client requirements. Car ceiling. Car ceiling is designed to be able to support two persons during maintenance operation without permanent deformation. Car ceiling is prepared also to mount emergency trapdoor, blower fan, and balustrade. False ceiling is the main source of lighting in the elevator car. There are many different designs for elevator lighting. Fluorescent lighting and spotlights are the most common lighting elements used for elevator lighting, and combination of two types can also be used. Emergency trapdoor assembly. Emergency trapdoor can be easily opened from inside the car by using triangular key and from outside the car without a key by turning the link to pull locking arms. Normally, emergency trapdoor size is 600 by 400 mm to permit the rescue and evacuation of passengers. Car operating panel, which is also known as COP. Car operating panel is a panel mounted in the car containing the car operating controls such as call register buttons, door open and close, alarm, emergency stop, and whatever other buttons or key switches are required for operation. Handrail. Elevator car in most cases is provided by a handrail at one side, two sides, or on all sides of the cabin. At least one side of the car has a handrail installed which can be used by passengers for support, including persons with disabilities. Handrails come with different finishes like stainless steel styles or painted in selected color upon client requirements. Elevator doors. Elevator door is of two types, manual doors and automatic doors. Manual doors. These type of doors are opened with the help of person who wants to enter the lift. It can be a single panel or collapsible door that protects the car entrance. Automatic doors. Automatic doors are the type of doors which are automatically opened as it is powered by a door operator and usually have a full height photoelectric curtain to sense the entry or exit of persons. Automatic doors are of two types, central door, telescopic door. In case of central door, during opening or closing, the panels move in opposite directions. Whereas in case of telescopic door, during opening or closing, the panels move in the same direction. So friends, I hope I have covered all the components of elevators in these two videos. So see you in the next video. Thanks for watching.